Students, in this module, we will learn to interpret the results of the binomial test that we have obtained from the SPSS software. So this was the output which we have got after entering the data into SPSS for the binomial test. So if we just look into this output, what we are given with, we have entered the data for the 10 males and the data for the 10 females. The objective of this binomial test was to test the hypothesis that the proportion of females is more than 60% in the sample information we have obtained. So in order to test, we have entered the data into SPSS, and this is the output we are going to discuss after we have entered that data. So students, if we just look into it, what we are going to do, we would have to make the comparison between the observed results and that of the expected one. So the observed proportion in this case is 0.5. So students, if you just look into the output, there is that observed proportion which is being specified as 0.1 for the females as well as for the males. Whereas the proportion we need to test is being given under the test proportion and it is specified as 0.6. Now if we just move on to the next column, that is being given as the exact p-value, which is one-tailed p-value, and it is being specified as 0.245. So students, if you just look into the next information which is being given to us is the exact p-value, which is being given for the one-tailed test, and it is being specified as 0.245. Now, as far as the exact p-value is concerned, students, यहाँ मैं आपको बताती चलूँ that this particular information is about the fish's exact p-value. So usually, when the sample size is small, we can't, trust on to the chi-square test or some other test for testing this sort of proportion. So in that case, we would have to apply the Fisher's exact test. So students, in order to carry out this particular test, we require the testing procedure. So there are certain steps which we'll have to outline under the testing procedure. So the first thing we would have to do is to design the pair of hypotheses. What we have done in case of the manual calculation about this particular problem. So the alternative hypothesis stated that the proportion of females is more than 0.6, which we need to test. So students, the second step specified the alpha, which is also the type 1 error, and it is being given in the statement as being 0.01. The next thing you would have to consider under the output is the p-value of the Fisher's exact test, which is being given to us as 0.245. So we are going to, make our conclusion on the basis of this calculated p-value and that of the observed p-value. Now, what is the observed p-value? Alpha is also known as the observed p-value. So students, the critical region, which is the next step under the testing procedure that specifies where to reject or accept our null hypothesis. So we will have to reject the null hypothesis if our p-value that remains less than our alpha value, which is 0.01 in this case. So students, we have concluded upon the comparison of the observed p-value and that of the calculated p-value that our p-value, which is 0.245, that is greater than 0.01. So it does not fall into the critical region. So we will have to accept H0 and conclude that the proportion of females in the statistics class is at least 0.6.